Welcome to another episode from the Veterinary Research Channel. Today, we will be discussing an insightful article titled The Value of a Head Turn in Neurolocalization, published in the Journal of Veterinary Internal Medicine in 2024. This research explores the clinical relevance of head turns in dogs, a common sign in neurological examinations, and challenges the traditional association of head turns exclusively with forebrain dysfunction. Historically, a head turn, sometimes interchanged with the term pleurothotonus, has been considered an indicator of abnormalities affecting the forebrain. Pleurothotonus describes the twisting of the head, neck, and trunk to one side, while a head turn involves only the head and neck. Other terms used to describe similar postural deviations include torticollis, laterocollis, and scoliosis. The study aimed to identify other regions within the central nervous system that could cause a head turn, whether the head turn occurs in isolation or with other postural deviations. The study was a multi-center observational prospective one, conducted across 6 veterinary referral centers. 49 client-owned dogs presenting with a head turn were included. These dogs had photographic or video evidence of a head turn, underwent a full neurological examination, and received advanced imaging such as magnetic resonance imaging or computed tomography for lesion localization. The researchers recorded the side and degree of a head turn, as well as any concurrent body turn or head tilt. The dogs were categorized into subgroups based on imaging results: forebrain, brainstem, cerebellum, or cervical spinal cord. Cases were excluded if structural changes were not identified, if multifocal areas were seen, or if one lesion affected multiple subregions. The results of the study indicated that a head turn is not exclusively associated with forebrain disease. Of the 49 dogs, 24 had lesions in the forebrain, 9 in the brainstem, 9 in the cerebellum, and 7 in the cervical spinal cord. Different disease processes were identified in these locations, including interaxial masses, ischemic infarcts, extraaxial masses, and non-traumatic hemorrhages. Interestingly, the researchers found different combinations of head and body postures based on the imaging location. Of the dogs with a head turn only, the majority had forebrain disease. Brainstem cases often presented with head tilts in concurrence with a head turn, while cervical cases commonly had a head tilt and body turn in combination with a head turn. In cerebellar cases, head tilts were often contralateral to the lesion. In almost all cases of forebrain disease, the head turn was ipsilateral to the lesion. A concurrent body turn was also ipsilateral in these cases. Other signs of forebrain involvement included altered mentation and behavior, compulsive circling, and proprioceptive deficits. In dogs with brainstem disease, the head turn was ipsilateral in all cases, with many showing a head tilt. A correct lesion localization based on the neurological examination was achieved in most cases. Other signs included proprioceptive deficits, changes in mentation, and nystagmus. For dogs with cerebellar disease, all head turns were ipsilateral to the lesion, and most had a contralateral head tilt. Neurological examination accurately identified the lesion location in all cases. Additional findings included ataxia, postural response deficits, and strabismus. In cervical spinal cord cases, the head turn was contralateral to the lesion. A body turn and head tilt were also commonly observed, both contralateral to the lesion. Neurological examination correctly localized the lesion in most cases. Other clinical signs included proprioceptive deficits and tetraparesis. The study further explored the implications of these findings in relation to existing terminology such as pleurothotonus, torticollis, and scoliosis. Pleurothotonus, often described as a head, neck, and body turn in the same direction, was only identified in a minority of forebrain and brainstem cases. Torticollis, characterized by a twist and turn of the neck, was observed in some dogs with brainstem lesions. Scoliosis, a three-dimensional deformity of the spine, was associated with cervical spinal cord lesions, where head turn, head tilt, and body turn occurred in the same direction. The authors acknowledged several limitations of the study. The pathology identified could be more extensive than apparent on imaging, and the sample sizes for each region were disproportionate. It was also difficult to determine whether neurological deficits resulted from direct or indirect compression. The study also recognized that head turns and head tilts could be static or positional, which was not fully captured on photographs. Despite these limitations, the study provides valuable insights into the clinical relevance of head turns in veterinary neurology. It challenges the historical association of head turns exclusively with forebrain disease, demonstrating that lesions in the brainstem, cerebellum, and cervical spinal cord can also manifest as head turns. The concurrence of head tilts and body turns can occur with lesions in various locations, making specific documentation of posture necessary. This study underscores the importance of a comprehensive neurological examination and advanced imaging for accurate lesion localization in dogs presenting with a head turn. Traditionally, head turns have been linked to forebrain issues. This study found that while forebrain lesions often cause ipsilateral head turns, issues in the brainstem, cerebellum, and cervical spinal cord can also lead to head turns. For example, one dog with a suspected seizure-induced change in the piriform lobe showed a contralateral head turn, possibly due to stimulation rather than loss of function in that area. In brainstem diseases, head turns were always accompanied by a head tilt or body turn, or both, highlighting the complexity of postural control in this region. The interstitial nucleus of Cajal and descending interstitioseminal fibers play a direct role in controlling cervical muscles, meaning that disruptions in the brainstem can affect both horizontal and vertical head positioning. Cerebellar lesions, especially in the rostral vermis, often resulted in ipsilateral head turns with contralateral head tilts. The rostral vermis is crucial for coordinating gait and adjusting the posture of the head, trunk, and legs. Cervical spinal cord lesions also never presented with isolated head turns. They typically involved concurrent body turns and head tilts. Damage to either the dorsal or ventral gray matter can cause muscle imbalances leading to head and neck deviations. The study aimed to clarify the use of terms like pleurothotonus, torticollis, and scoliosis, which are often used interchangeably. Pleurothotonus, or Pisa syndrome, involves lateral flexion of the spine without vertebral rotation and was not consistently found in specific brain regions. Torticollis, a twist and turn of the neck, was observed in some brainstem lesion cases. Scoliosis, a three-dimensional spinal deformity, was commonly associated with cervical spinal cord lesions. Understanding the complex interplay of visual, vestibular, and proprioceptive signals is crucial for accurately diagnosing the underlying cause of a head turn. Disruptions in any part of these pathways can lead to postural deviations. Thank you for listening to the Veterinary Research Channel. A link for the referenced paper is in the video description. Remember to test your knowledge by answering the questions in the description, and as always, keep those minds inspired, hearts light, and tails wagging.